All right, so let's try to go over this Lab 12 and see if we could make more sense of this. Let's start by going into the Week 9 folder. And if we scroll down, it says this week's lab will be handled a little bit differently than others. I provided a new copy, so don't use the one in the manual. Watch the provided lab video. So that's going to help you to complete all the pages of the lab, except for these last four pages that I want to submit separately, pages 155 to 158. We're going to have to do something a little bit different that I don't cover in the video. All the materials that you need to complete Lab 12 and the oxygen saturation activity can be found in the Week 12 folder. So, all right, so let's check this out. We go down here to the Lab 12 folder. It says materials for Lab 12. Um, I only want to collect pages 155 to 158. And of course, we're going to submit them as PDF files. That's nothing new. And there's not going to be a disorder project. Okay, so let's open this folder and take a look at what's inside. When we do that, you'll see that the lab pages are there and the rubric is here. And then we have this thing called the oxygen saturation simulation. Now, when we click on this, you could choose to download it from here. And when you download it, you could reopen it. And I have mine opened up in Cami because this is a program that I like to use to write. And again, it starts at the very beginning, and all this I cover in the video. So all that is covered in the video. We have the microscopic observations, like we always have. Same thing. That's all covered in the video. Then we get to these pages for the oxygen saturation activity, which starts here, and it shows you the pulse oximeter, and it tells you what it reads. It reads your pulse rate, how many beats per minute, and it tells us how much oxygen we have in our blood, and it measures it as a percentage of saturation of oxygen. And that should be close to 99 or 100 is ideal, but nobody's really 100. Most people are between 98 and 99% normal oxygen. And you operate this by putting it on your finger like this. And you can see it'll give you your pulse rate and then your percent oxygen. So this is normal. So 97 pulse rate, this is a little high. So this person's probably been walking around or whatever. At rest, it should be about 70 or 80. And then we have this, the lab. These are the pages that I want to collect. And the question, or the observation rather, starts off by saying the heart rate and breathing rate changes based on oxygen demand of our body from when a person is at rest and when they are exercising. All right, so obviously, when we're at rest, our pulse rate will be one thing, but then when we get up and start doing exercise, our pulse rate should change, or it might change. Um, so that's question number one. How does this change in activity affect your heart rate? But the question number two says, how does the change in activity from being at rest to exercising affect your blood oxygen level? So here, this is a hypothesis. This is where you're going to want to make a guess. So your hypothesis one should go with question number one. So you should say, if a person goes from resting to exercising, then their heart rate will increase or it'll decrease or it'll remain the same. So that's where you have to decide what you want to say. It's your guess. It's not mine, right? And then down here for hypothesis two, you're going to predict how does the change in activity affect your blood oxygen level. So you're going to say if a person goes from resting to exercising, then the percent oxygen saturation will, and again, you're either going to say increase, decrease, or remain the same. All right, it's your prediction. And then as we continue down, we're going to talk about just like basic experimental stuff, identifying dependent and independent variables. Independent variables are things that we are controlling, and dependent variables are things that we're looking for. So I would say independent variable would be the amount of activity. And there's really going to be two choices: at rest or after exercise. The dependent variables that we're looking for are going to be the pulse rates in beats per minute and the percent oxygen saturation. Okay, things that we want to control. Well, between all the different subjects that are going to be participating, we want to make sure that they are all doing the same type of exercise, maybe. And other things that we can control is the amount of time that they're doing exercise for, maybe the temperature of the room, things like that. We don't want outside factors affecting our results. So we would write these types of things in. What measurement did you use as a control in this investigation? So we're always going to be comparing our data to the data that we receive at rest. So, what measurement did you use as a control? Our pulse rate in beats per minute at rest is our control, and our saturation percent oxygen at rest is another control group. And why? Because we need that. Because after exercise, we want to look at these numbers again, and we're going to come back and compare it to these numbers at rest. Okay, so that's if we're going to put together a normal looking scientific experiment, we have to have a control group. We have to have a set of data that we need to compare our experimental data to. And in this case, the experimental data will be the data that we collect after doing exercise. So here's our methods. Determine the resting pulse rate and oxygen saturation at rest. Record them on the table. And then after that, you're going to run in place for 2 minutes, measure both pulse rate and oxygen saturation immediately. We're not actually going to be doing this ourselves, but if we go back to the lab, in the folder, I have another thing here called oxygen saturation simulation. And when you open that up, you could hit this download button. And when you do hit the download button, you could play it, right? And it's interactive. So this is where we have our, it's again, it's reviewing the pulse oximeter. Click when ready to use. So this is participant one. They're going to be click to place the pulse oximeter on their finger, and now it's on their finger. They're at rest. So there's our first data point. You want to write this down on a piece of paper. Subject one, participant one at rest has a pulse ox of 98% and a pulse rate of 64 beats per minute. Make sure you write that down. And then when we click continue, now the person is going to run in place for 2 minutes. They're running in place. Let's see if we could scooch ahead. And then we're going to put the pulse oximeter on their finger again. And now we have a new set of data. This is our experimental data. 98 pulse rate and pulse ox of, I'm sorry, beats, the pulse rate has elevated up to 117, but the pulse ox, the oxygen saturation rather, has remained the same at 98%. The beats per minute has gone up. All right, so that's interesting. So you want to write that down, record the data for participant one. At rest, their pulse rate was 98 beats per minute. I'm sorry. Their oxygen saturation was 98%. Their pulse rate was 64 beats per minute. After exercise, their saturation of oxygen stayed at 98, but their pulse rate went up to 117. Now we can move on to participant two. Here's participant two. At rest, saturation oxygen 99%. That's very good. Resting pulse rate pretty low, 62 beats per minute. Click on it, let them run around. They're going to run around. 2 minutes. And here we go. They're done. We put the pulse oximeter back on, and their oxygen has remained the same, but their pulse rate has elevated up to 125. So again, you want to record this data for each participant. Now, is there a faster way to do this? Yes, we could get out of this and just go here, right? And when you scroll, you go to the first person, there's their resting data, record it quickly, and then quickly scooch ahead, right? And there's their exercise data. And then you could quickly go to the next person and then scooch ahead and collect their exercise data. And then the next person, there's their control data. Scooch ahead. It's nice because they color the people different colors. Their experimental data. Next person, control data at rest. Scooch ahead. Okay, experimental data. And you keep doing this. There's 6 participants. Now, when we go back to the lab paper, this is where we want to write this stuff in. When we go to participant 1, we have all their information written down. Their pulse rate was 64 beats per minute, and their blood oxygen was 98% at rest. Now, when they exercised, their pulse rate went up to 117, but their blood oxygen remained steady at 98. All right. And participant 2, very similar situation. They had a resting pulse rate of 62 beats per minute with a 99 pulse ox. And then after exercise, this went up to 125, but this stayed at 99. Participant 3 had a resting pulse rate of 71 with a blood oxygen at 99. After exercise, their pulse rate went way up to 133, but their oxygen level stayed at 99. And this is how you would continue to do this. And then you would collect the average. You would average these up, okay, and collect the averages. Now we have to do a bar graph. It says bar graph, so make sure we do a bar graph. Average heart rate at rest and after exercise. So once you get these heart rate averages, right, at rest, you're going to add up all these 64 plus 62 plus 71 plus the other ones are 68, 75, 60. Divide by 6, get the average. It's going to be something 60 something. And then you're going to do the same thing over here, get the averages of this column because this is the pulse rate after exercise. So you're going to add up all these numbers, divide by 6, get a number, and you're going to put them in the bar graph down below. So the x-axis is going to be the level of activity. We always put the independent variables down below and the dependent variables up here. So this is the rest. And over here, we could put after exercise. And then we could choose one of these columns here to do our bars. And over here, you're going to put pulse rate, beats per minute. And you're going to probably do 10, 20, 30, 40, 50, 60, 70, 80. Yeah, you got to go more than 10 actually because the pulse rates go over 100. So you might have to go by 20s here. 20, 40, 60, 80, 100, 120, 140. So at rest, after you average them, I'm going to assume that the average resting pulse rate was about 60 something. So choose one of these columns here and get it to the number that it is. And over here, it probably went up to, I don't know, I forget. So maybe like around 120 was the average of the people's pulse rate. So clearly we can see at rest, the pulse rate's way down here. And then after exercise, the pulse rate went way up here. Now you're going to do the same thing down here below, but you're going to use the different set of data. You're going to do, it says blood oxygen saturation percent, blood oxygen saturation. But down here, it's going to be the same thing, level of activity. And you're going to do at rest again, and then after exercise. And you're going to get the averages. But remember that those numbers didn't really change much, right? So we have 98, 99, 99. It's probably 98, 99, 98. So it's probably going to be something like 98.5. And over here, they didn't really change. So these numbers are going to be the same. So about 98. So for this one, you can go up by tens. 60, 70, 80, 90, 100. And at rest, the pulse ox was almost at 99, 98, something like that. So we put a bar graph going up there. And then after exercise, same thing, almost up to the very top, showing very little change. All right, so it'll look something like that. So we don't see a change in blood oxygen levels from being at rest to being after exercise. And there's a very good physiological reason for that, because when we're exercising, the body's trying to keep oxygen levels constant, right? Because when you're exercising, the muscles are requiring more oxygen. So we have to give the muscles more oxygen. Well, how do we give the muscles more oxygen? Number one, by breathing more. You're breathing heavier, putting more oxygen in the blood. And number two, by delivering that oxygen to the muscles that need it. So you're going to be pumping your heart faster. So if we're doing those two things, the blood oxygen levels should remain the same. So that's an example of maintaining your homeostasis. So what did you observe? What did you observe when it came to heart rate? What did you observe when it came to blood oxygen saturation? Give a reason. All right, well, I kind of just talked about it a little bit. So put that into your own words. Answer these last couple questions, and then that's it. Okay. So I think this video will help you enough. If you have any questions, feel free to email me. But I think you'll be okay. But don't forget, remember to when you're done with this, submit only these 4 pages into the assignment. Where is that? Let's go back to the lab materials folder. No, we want to go back to week 9. No, I was right the first time. It's in here, lab materials for lab. And then the submission goes here. All right. You submit it as a PDF. All right. So I hope this video helps. And, if you have any questions, email me. Okay. Good luck.